right, calculus, we're going to move into chapter 7. So in the beginning parts of chapter 7, we're going to find the area between two curves, and then in 7.2 and 7.3, we'll actually be finding the volume, which results in taking the area of a region and rotating it around an axis. What we start off with just area. Okay. Prior to this lesson, you knew how to find the area under a curve. That area was bounded by the x-axis or maybe the y-axis, and you just integrated. At that time, we were doing the area of rectangles, and we added them all together. We did summations with limits to bring that to our integration. So those were the Riemann sums that we were working on then. All right, so back then when I taught you the Riemann sums, we were doing the area of rectangles and adding them together. So this was like the width of your rectangle, and then f of x represented the length. So if I drew in my rectangle from here to here, that's f of x, and then this right here represented the width, so that was your dx. We'll keep that in mind as we move on to the next slide. In today's lesson, you're going to be finding the area between two curves. Well, what we need to do is consider that if we're finding the area here, and we'll call this area A, that's just the area underneath curve F. Okay, if we're going to be finding the area we'll call B, that's just the area under curve G. All right, if we're interested in finding this area in the middle, I'm going to call it C, then we're going to be subtracting the area B from area A. So this integration will look like the area of the whole thing minus the area underneath. So basically, you're going to be taking this top curve, this is function f, and this is function g. So we're going to take the top minus the bottom, which is this right here. Again, that is the height of your rectangle. It's always going to be top minus bottom, or if it's a horizontal rectangle, it's going to be right minus left. So top minus bottom, and then dx represents the width of that rectangle. Get used to graphing with these examples, with these problems, and drawing in the rectangle. And that rectangle, drawing it in, is going to be crucial for when we move into lesson 7.2 and 7.3. All right. Hopefully you have some graph paper at your house where you can graph these functions. You need some precision in your graphing. You need to be able to find points of intersection and so forth. And if you can't find those off your graph, you're going to have to use substitution to find those points of intersection. I'm going to start off by graphing this function, and I can see right away that this one does factor. So it is a parabola shifted one to the left. So here's my vertex. I'm looking at x values between -2 and 2. If I plug in 2, I'm going to be at 9. And if I plug in -2, I'll be at 1. If I plug in 1, I'll be at 4. So I'm just getting a few points on here. It's going to be like a fish hook kind of shape. All right. The other equation is that of a line, so it has a slope of 2. Let me erase that. It has a y-intercept of 5 and a slope of 2. So the area I'm finding is this area that I have here in pink. All right, again, I want you to get used to drawing in the rectangle. The rectangle is going to help you identify which function is above and which function is below. Now my blue function is f and my green function was g. So in this problem, I see that the green is on top of the blue. So the area is going to be from -2 to 2. The green, so 2x plus 5 minus the blue, and then dx. I'm going to clean that up first. Integrate. Plug in my x values. And that's 32/3. Okay. So with our first example, our bounds were given. So some problems you might have the bounds given, sometimes you might not. So in this case, it just says to find the area. And this is where I was talking about. You want to be super careful when you graph, and hopefully you have some graph paper at home you can use. All right, 2 minus x squared is a parabola. It's starting up here at 2, and I know it opens downward. When x is 1 or -1, I'm at 1. When x is 2 or -2, I'm at, what, -2? Okay, so there's a sketch of my parabola. The other one, and that is function f, I'm going to have y equals x. So that's just a line that cuts through 0, 0, 1, 1, 2, 2, and so forth. Now, I can see my points of intersection. So here's my A, here's my B. But if you can't see those on your graph, you'd have to find them algebraically, which means you're going to have to use substitution. So if they both equal y, they equal each other. And I'm doing substitution then with some factoring to get my two values, -2 and 1. All right, so if we're going to find the area, and the area would be of this yellow region here, because the area that you're finding is always bounded, so it's always going to have boundaries. -2 to 1. The top curve is 2 minus x squared, and the bottom curve is x, so I take the top minus the bottom. We're going to clean that up. Actually, there's no cleanup, so let's just go ahead and integrate. And once you plug those values in, you should get 9/2. And let me just double check my work here. Yep. All right. We're going to do one more example in today's notes, and then we'll stop there. So we want to find one of the intersecting regions of sine and cosine. So I know sine, let's do we'll do sine in pink. I know the sine of x, the sine of pi over 2 is 1. Okay, so here's that curve. And I know cosine starts up here and it goes like that. So, all right. Okay, so it says that we want to find the area of one of the intersecting regions. So you're actually going to be finding this area here. Okay, the sine and cosine are exactly the same at pi over 4. And this would represent 5 pi over 4. And so what we're going to do is we're going to take our pink curve, subtract our green curve, and we're going to go from pi over 4 to 5 pi over 4. So we're going to have cosine of x, actually the negative cosine of x minus the sine of x, from pi over 4 to 5 pi over 4. Okay, we're going to be working that out. I'm going to switch colors so you can see it. So that's going to be negative radical 2 over 2, the opposite of that, minus, let's see, that's going to be also the negative, yep, and then minus radical 2 over 2. So basically you're going to end up with 4 radical 2 over 2 radical 2. Oh, how about a 2 in front of there? There we go, 2 radical 2. Okay, that's where this video is going to stop. I'll assign some homework that covers just this part of the lesson. Let me know if you have any questions.